It turns out that Tony's quite right about humility being one of those things that's really hard to detect, but I think I have a system, so you're going to have to help me out here. So what I need you to do is you need to stand up, so everybody has to stand up. This is the audience participation portion of tonight's program. Okay, so here's what you're going to do. I want you to take both of your hands, nothing in them, stretch it nice and high, get a good stretch, get a good stretch. Okay. So now you're going to bring them down in front of you, and I want you to take your two hands with your fingers outsplayed, and I want you to place them together and interlace all of your fingers, right? So do this kind of thing, right? And then take a look down at which thumb is on top. You got it? Okay, which thumb is on top? If your left thumb is on top, that means you're a great thinker. Got it? Okay. If your right thumb is on top, then that means you are incredibly humble. What are you doing? Yeah, some people are like, oh, I'm just going to switch right now. Okay, and just for the smart Alex in the crowd, if both of your thumbs are right next to each other, then that means that you think you're very humble. So, have a seat. There we go. You got your stretch. That's good. The seventh inning stretch. Okay. So, when asked to talk about humility, my first reaction was, no, you can't possibly want me to talk. Because I think that's what you're supposed to say, right? When somebody asks you to talk about a topic like that. I actually got really excited by the prospect, but with a sense of, what does humility look like in and around science? So what is it about science that could tell us anything about humility, and what role does humility play in science and the work of science and scientists? I will tell you that my first thought when I was kind of trying to come up with something to talk about was one of my first memories right after undergraduate. I just finished my undergraduate degree, and I got a job working in a laboratory. And this was a government laboratory, and we were designing, all I can tell you officially is that we were designing and testing different types of ceramic material that may or may not have gone on the outside of certain vehicles that would find themselves in combat situations. It was tanker. We were making tanker. I can tell you that much. But anyways, so we were doing this stuff with these ceramics, and it's a long story, but short answer to the long question of what does this have to do with humility is, I walked in the first day and I was sitting in a staff meeting, and the head of the department, this research scientist, brilliant man, I actually read papers by him. He was one of the first people to use this thing called the photoacoustic effect in being able to study and analyze ceramics. I'm like, oh gosh. And we're sitting there, and there's like 10 people in this one laboratory talking to this one guy, and he came in and he said hi to people. He obviously knew some people. And he kind of looked around, he saw me, and he said, hey, you're new. What's your name? And I shook his hand. I said, I just got a job here, I'm a little nervous. And he said, no problem. And we got through the meeting, and at the end of the meeting, he went around and he asked every person what they thought in terms of next steps for a research design should be. And he went around and talked to all the research scientists, and then I'm thinking, okay, I'll just wait this one out. Then he got to me and said, well, what do you think? And I just sat there for a second, because I had not considered that I was going to respond. And my initial thought was, why would you care what I think? And I kind of said, you probably don't want to know what I think. And he said, oh, no, actually, I do very much want to know what you think. I said, well, this is like my first week. I guess I don't understand why we do this particular procedure first, and then we have to wait to do the second procedure. If we did them in a reverse order, it seemed like it would go faster. And he goes, that's why I care. Because that was a smart answer. I think maybe we can change some things around and get more efficient. I said, sure. I think I did something good. I was so excited. I left the meeting. I thought, wow, that's really cool. Turns out, somebody else had the same brilliant idea a couple of weeks before, and they were going to change the procedure anyway. But I didn't know that. I hadn't been there long enough. And so I felt I was on cloud nine. Super uber scientist was telling me that I had a brilliant idea, and it really worked. And I thought, wow, how cool to be able to sit there, listen to ideas, and be willing to entertain ideas that from me. I just got my degree. How would we know anything? How would I know anything? So I want to talk to you a little bit about kind of the role of, can I get a little bit about humility in science. And so I'm going to start kind of the way Tony did, and start by saying, hey, look, humility in science doesn't mean these things. So a lot of times when people think about humility, and this is going to sound very familiar, it doesn't mean meekness. People who are quiet are not necessarily humble, right? It doesn't mean unconditional deference. It doesn't mean me sitting there in the meeting going, you couldn't possibly want anything that I have to say. He obviously did. He was very concerned with what I had to say. Ignoring one's own beliefs. That's not humble. That's, in science, that's silly. Like not paying attention to your own beliefs, that's dangerous in a lot of cases. So in a thumbnail sketch, what does it look like? What is humility in science? I think it comes down to at least these three things. First, and this is going to sound very, very familiar compared to the other speakers so far, it's openness to being wrong. Not just openness to other ideas, openness to being wrong. The idea that when you sit down to do work, you could be wrong. Your results could be wrong. Those of you who've had a statistics class up to this point, that you probably understand what I'm about to say. In statistics, we build into any confidence interval or hypothesis test the understanding that there is always a chance that we're wrong. Always. So any statistician will tell you, statistics is about never having to say you're certain. You never really know if you're right. The second one, respectfully considering that first word is important. The ideas of others, not just others that you happen to be in the room, but all others. Being patient and listening to what other people have to say. Humility is paying attention. And then last but not least, this one's a little vague, but I'm going to talk a little bit about it more. Respecting the power of science in the hands of imperfect humans. So respecting the fact that science, if wielded incorrectly, can be an incredibly dangerous thing. And since the people who wield it are people, and we're all imperfect, we have to be willing to accept that if we're in charge, that we might be screwing up. And being willing to kind of take a step back, listen to others, and evaluate what's going on, and say, maybe we should change what we're doing here. So humility does mean these things, but it can mean other things as well. So what I wanted to do is talk a little bit about kind of the mechanisms that are built into science, the mechanisms that are built into scientific study, scientific inquiry, for generating or cultivating humility. Now, sometimes people think scientists are the least humble people in the world. Again, mostly because they have a mistaken impression of what humility looks like in science. So here's a little snapshot. Take a look. Does it look familiar? Have you seen something like this before?
Yes.
If you've ever taken a science class, yeah, you've probably seen this a couple of times. What's this collectively called? What would you call this thing right here? Hey, it's a scientific method or scientific process, depending on what class you were in. And it turns out that whether you're in astronomy, or you're in biology, or geology, or physics, or chemistry, or, yes, even mathematics, we use a variant of this in the way we study and the way we develop knowledge. Because notice at the top, it's all about asking questions. And then as you go down, we test. We look for evidence. And as you can see, it's kind of hard to point out up here. There's a laser pointer, I think. There we go. There's a little bit of a dark line here going back. Once you get down and you analyze your conclusions, sometimes you have to troubleshoot, and you wind up going back kind of to the drawing board. Being willing to accept that sometimes science means I got to do it over again because I didn't get it right the first time. Or what I was looking for is not quite what I was doing in the laboratory, what I hoped to find. I wasn't going to get there this way. Here's another image. This one is, I labeled it so you wouldn't have to guess, but this is kind of a cartoon image of what the peer review process is all about. So scientists, when they come up with a finding or a result or their work after the process of their method, they want to share it with other people. That's how we know and how we build knowledge. But it's not as easy as you just climb to the tallest building and you shout, hey, guess what I found? Because science has a built-in procedure to make sure that what people are shouting from the rooftops actually looks like what other people can verify and what makes sense. And so this peer review process, you'll notice it starts off with a person submitting some work to a group of others. And the group of others looks at it and either chooses to say, hey, that's cool, we should publish this, or they send it back and go, I think you're going to have to try something else, or I'm not so sure about what you were saying here. It is incredibly humbling. And when I say this is an either or, this is almost entirely, always, getting kicked back. Very few people submit a paper and it just flies through with no revisions. It just doesn't happen. Right? Because scientists expect to get pushback. They expect their colleagues and their peers to give creative and constructive feedback that helps. And then the last one, the last little image that I'll put on here is a little teeter-totter. I like to use teeter-totters to show indirect relationships. And so there's an indirect relationship between two things in science, always, in any science. Whether it's mathematics, or whether it's physics, or biochemistry, it doesn't matter. The more certain we are about the results of what we're finding, the less generalizable those results are. Right? This is why when biologists want to study the effects of, say, smoking on humans, they don't go out and say, and put people in cages and say, you must smoke. Right? They go into a laboratory and they take some cells and they expose those cells to certain chemicals, which is really, really, really good for creating certain results. I can be really confident that the experimentation is very, very certain. The downside is those cells in a petri dish don't generalize very well to people out in the real world. So there's this trade-off. Nutritionists have the same problem, right? I don't know if you've ever tried to figure out what's good for you to eat, right? But depending on the day, depending on who you talk to, they say, eat all this stuff, but not this stuff. And then you talk to somebody else and they say, eat all this stuff, but not this stuff. It's not because they don't know. It's because when we talk about generalizing results, your results may be generalized from a particular study. Somebody else's results from another study, and those are very different studies, right? And so this is baked into science on purpose. We do this, and it's humbling to do science. It's humbling to be a scientist and to run into, whether you're running into the problems of a method problem, or you're running into the problems of trying to share your results, but it's not quite right. You need to clean it up. Or having those lovely results that aren't very generalizable, and everybody just goes, who cares? Or you have super important results, and then they start to ask you about your methods, and you go, oh, they're not very generalizable, or I'm not very certain about these results, but they're really generalizable. So last little slide, or last little bit down here, I didn't realize we were going to have the heads so in the way. It's a little quote by a scientist and a writer, mostly famous for writing science fiction, but he's kind of held up by scientists as a really good science writer. And the quote is, experimentation is the least arrogant method of gaining knowledge. The experimenter humbly asks a question of nature. I think that's a nice synopsis of the way scientists think about humility. Right? You're approaching nature, asking a question. You're always putting yourself in the role of learner, not expecting to get the right answer, but you want to see what happens. So for the very last slide, what are some consequences of humility in science? Well, one consequence is that we can sometimes be so humble in our approach to science that we lose sight of bigger pictures. Right? You get stuck in your little silo. You get stuck doing your laboratory experiments, and you forget that this is part of a bigger story. That's the forest for the trees scenario. And sometimes scientists get accused of this. It's like, oh, you're just buried in your own research. That's all you see is your own research. That's true, but that's good. That's good for science, but it's bad in terms of keeping in mind that you're part of something bigger. The other one, this is the nightmare audience for scientists. You show up to talk to people, and you've got all varying degrees of they're not ready to listen. Right? You heard people up here, the previous speakers, talking about keeping an open mind, but it's not just about openness. Right? My favorite quotes, I can't remember what it is off the top of my head, but it's keep an open mind, but not so open that your brain falls out. Right? If you've ever heard that before. It's a fun quote. But this idea that if you're not open to new ideas, to being able to share not just others' ideas, but to share your own ideas, then nobody benefits. Nobody benefits. Professor Cleveland mentioned the foundations of higher ed, we want to share ideas so that we can all benefit. And then I've got two little consequences, which I thought are fun. This is one consequence. We have an 11-year-old, this is last year, just a year and a month ago. This 11-year-old won a prize, the 3M Young Scientist Prize. Won a prize for developing a better lead detector. It's a portable lead detector that you can stick under the faucet and get the measurements of lead in the water. Can you imagine maybe where that could be useful in the United States these days? You know, she's from Colorado and out in the middle of nowhere. And the problem was that before her invention, there are two ways to measure lead. One way is you take a sample and you send it to the EPA and you wait however long it takes them to get the results back to you. The other method is highly, highly uncertain. And it's slow, but it's incredibly uncertain. It involves strips of test paper. It's really hard to do. She, with some help from a couple of adult scientists, came up with this idea, developed it, and won a big prize. And this past year, there's a 13-year-old. This 13-year-old from Minnesota developed an artificial intelligence algorithm that helps MRI machines figure out where your pancreas is. Because it turns out spotting your pancreas on an MRI, I don't know, maybe Joe can tell me, it's pretty hard to do. And Joe's like, I don't have any problem with it. But the trouble is, we want to be able to do this real time to be able to help people who are pancreatic cancer patients. And so this 13-year-old steps into the fold and develops this system for being able to, in real time, figure out where a patient's pancreas is on the MRI scan so that we can help cure their pancreatic cancer. And both of these people, I mean, these are kids, right? And the reaction from the scientific community was not good.
Kids are not allowed.
The reaction from the scientific community was awesome. Thank you so much. Now go back to work and find something else cool that we can learn from. So I'll just put my little information up there. If you're interested in the slideshow and the information on here or anything that I've talked about, I'd be more than happy to share that with you. And I'll turn it over now to our last speaker.